Hi, this video is about refraction. Waves can be refracted when they cross a boundary between two substances that have different densities. Refraction changes the speed of a wave, which can change the wave's direction. Waves travel at different speeds through different substances. A wave will travel more slowly through a denser substance compared to a less dense substance. If a wave hits a boundary between two substances, the wave continues in the same direction. This is because all of the wave hits the new substance at the same time, and therefore all of the wave slows down at the same time. We have a diagram that shows this. Here we have waves which are indicated by the blue downwards arrows. The wave is travelling from left to right, which is indicated by the black arrow. We have two substances, which is the light blue and the light green. The light blue substance is less dense than the green substance, which is denser. Our wave is travelling from left to right, and as the wave enters the green substance, it travels at a slower speed. This is because the green substance is denser compared with the less dense blue substance. So when the wave travels through the blue substance, it travels at a faster speed. Because our wave enters the green substance at a perpendicular angle, it means that the whole part of the wave slows down at the same time. This results in the direction of the wave remaining constant. We are now going to change our scenario slightly and say that our wave hits the new substance at an angle. This results in the wave changing its direction because of refraction. So we have the same two substances as before. We have the lighter, less dense substance and the green substance that is more dense than the blue substance. Our wave is travelling in a rightwards direction. As the wave travels right, the top part of the wave hits the denser green substance first. This results in the top part of the wave slowing down, and this causes the wave to change its direction, whereby it moves in a more leftward direction. We are now going to have a look at a glass window example. This is where light travels through air, then through glass, and then goes on to travelling through air. When light hits a glass window, most of it can pass through the glass. Some of the light is reflected off from the glass window at the same angle that it hits the window. Remember that the angle of incidence is equal to the angle of reflection, and remembering that both of these angles are measured against the normal. The glass is denser than air, and this causes the wave to slow down. As the right side of the wave enters the glass first, the right side of the wave slows down first. This results in the wave changing its direction, whereby it moves in a more rightwards direction. When the light reaches the other side of the glass, it is refracted again because the wave hits a new substance. The right side of the wave enters the air first, and this part of the wave speeds up first, resulting in the wave going in a direction that is more leftward. Most of the light enters the air on the other side of the window, but some of the waves are reflected as the light enters the air. Beyond a certain angle, known as the critical angle, all waves are reflected off a substance. An example of where this occurs is optical fibers. Optical fibers use infrared waves or visible light to send information across long distances. The waves are reflected off the sides of the optical fibers, and this is how the information travels from one place to another. For more videos, content, quizzes and past papers, go on to www.elevise.co.uk.